will be given in the formula list, but it's strongly encouraged or advised that you memorize this formula so that during exam, when you're using it, you'll be able to apply when the question needs. This addition formula is very similar to what we learned in chapter 8.1, whereby we make use of all these addition or subtraction formula to get answers of Trigo angle such that our answer will be in exact form or in search form. And all these addition formula won't be used in proving of Trigo identity, so it's just purely application. So take a look at the example. So for example, so all these addition formula you do need to memorize. And how to memorize? The easy I will show you all last time when I'm a student how do I go about memorizing them. For example, the first one, sine bracket a plus b. Last time as a student, what I did last time is you can see the pattern of for sine bracket a plus b is always sine a cosine b. Then after that, this sine is plus following whatever that is in front, and after that will be a flip, which is swapping the position, which is cosine a sine b. And this is the same as the next one will be sine bracket a minus b. Same thing, if it's minus, here will be minus, and the flipping of sine cosine cosine sine is the same as the plus. So this is a pattern for cosine addition and subtraction. For cosine bracket a plus b will be cosine a cosine b is cos cos sine sine, and but the sign here is opposite, plus become minus, then minus sine a sine b. And the same thing apply for cosine bracket a minus b, and it's the only difference with the plus is that initially in the bracket is minus, once you apply the formula it become plus. And for tangent bracket a plus b, it will be equals to tangent a plus tangent b, whereby the sign is the same, and the denominator will be over 1 minus tangent a tangent b, so it will be the denominator sign will be opposite. And for tangent bracket a minus b, will be tangent a minus tangent b, so the sign is the same, and the denominator will be opposite, so become plus over 1 plus tangent a tangent b. I say again, all these formula will be in the formula list, but it is strongly encouraged you all to memorize, so that when it comes to applying, you don't need to flip to the second page of your O-level paper, exam paper, to refer and decide which one to use. So do take note. So let's take a look at an example. So if you still recall, in chapter 8.1 we learned about the three general or basic angle, or the general angle that we need to know, 30, 45 and 60. So we base on these three angle, 30, 45 and 60, to use it in our addition or subtraction formula of the Trigo to solve such question. For example, we are asked to, without using a calculator, express each of the following insert form. So they want cosine 15. Cosine 15, we don't have the ratio of cosine 15. Even if you key in calculator cosine 15, you'll be getting a decimal value. So what happened? We make use of all the general, the three value, the three common angle that we have learned in 8.1, which is our 30, 45 and 60, and try and error whether is it plus or minus. How do we get 15 degree? So if you look at the example I've given, it's actually cosine bracket 60 minus 45. So this gave us 15 degree. Okay, so 15 degree. So with that, we apply the cosine formula. So we cosine, this will be 60 will be A, 45 will be B. So cosine A cosine B plus sine A sine B. 60 and 45 degree, these two are what we've learned in chapter 8.1. So just key in calculator, then you square root so that we have a nice surds. And after that, you combine them together. Do take note that this is not final answer, because whenever in A math, if we have a fraction and the fraction contains surds in their denominator, we need to rationalize the fraction. So what we do, we rationalize, we times square root 2 over 2 and not 2 square root 2, because the bare minimum is times square root 2 over 2. You still can multiply with 2 square root 2 over 2 square root 2, but your working will be longer and it's not necessary. Then with that, our final answer is square root 2 plus square root 6 over 4. Do be mindful. Then over here, we will have sine 187 cosine 52 minus cosine 187 sine 52. You can see from this question the pattern is sine A cosine B minus cosine A sine B. So because of this pattern, if you refer to formula list, the addition formula is actually sine bracket A minus B. So if you take, which means that A is 187, B is 52. So because of that, it will be sine bracket A minus B, and you'll get sine 135. Next you say, hey, sine 135, we have not learned this value, and plus we cannot use calculator. But if you sketch, sine 135 is the angle that hypo has rotated. So if you refer, hypo is in second quadrant because it's sine 135. So if it's sine 135, we use the basic angle, which is 45, is equivalent to, this one is equivalent to sine 45. So sine 45, if we key in the calculator, is 1 over square root 2. And because second quadrant sine is positive, so it's positive sine 45. And because it's 1 over square root 2, denominator is square root 2, we have to rationalize the denominator, multiplying with square root 2 over square root 2. This is how we do such question. Take a look at, I think next one is questions already. Come, take a look at the question. One more example. So for example, part C. Okay. You are asked to find 1 minus tangent 15 over 1 plus tangent 15. If you refer to the formula list for the addition formula, it is equivalent to your tangent, whereby here is 15 degree. Like I said, we have never learned 15 degree. We only learn 30, 45, 60. So we have to split. So if you recall, tangent 45 is 1. So I change the 1 to tangent 45. And tangent 15 remain. And since tangent 45 is 1, the denominator here, tangent 15, is equivalent to 1 times tangent 15, or tangent 45 times tangent 15. So because of that, our 45 is A, our B is 15. So, and here is minus, so we will follow. So A, tangent bracket A minus B, and we have tangent 30. Tangent 30, if you use calculator, is 1 over square root 2, and because denominator contains a surds, so we have to rationalize by multiplying square root 3 over square root 3. This is how we go about doing the question. So now take a look at the practice question, whereby over here the first one we are asked to do is sine 15. So sine 15, same thing. Think of two value, which is 30, 45 and 60. These three angles that we learned so far. How do we make use of these three, whether is it add or subtract to get this 15. So there's a few choices. We can either take 45 minus 30 to get 50, or you can take 60 minus 45. Both will work. So over here, part A will be sine 15. So the selection will be, for me, I'll choose 60 minus 45 to give us 15. And here we apply formula, we sine A cosine B minus cosine A sine B. So this example similar have been done in the previous page, which is by using cosine. So making use of a calculator, which is over here, key in into a calculator what is the value for sine 60. If you key in sine 60, please key in your calculator. So let's take a look at mine. So sine 60 is actually square root 3 over 2. This one should be 45 just now. So cosine 45 we'll have 1 over square root 2, then cosine 60 half sine 45 is 1 over square root 2. So with that we multiply and simplify. So I have square root 3 over 2 square root 2 minus 1 over 2 square root 2. So with that, since the denominator are the same, so our fraction will be square root 3 minus 1 over 2 square root 2, and we rationalize times square root 2 over square root 2. So we'll have square root 6 minus square root 2 over 4. So this is the final answer without using calculator. For the part B and part C, there's nothing much. Actually, we because due to the nature of the question, we cannot follow the instruction of the cert. So actually, it's just doing the reverse. No, there's no certs for us to follow for part B and part C. The question just expect us to change it in using addition or subtraction formula to change it to a single trigo. So for example, the second part B, they say sine 37 cosine 25 plus cosine 37 sine 25. So it's sine A cosine B plus cosine A sine B. So straight away here is sine will be 37, and here is plus, will be 37 degree plus 25, and equals to sine 62 degree. So this one it's not, these two B and C is not supposed to be the same, having the same instruction. So this is what actually the question wants, because we can't change this to subform. Then the next one for part C will be tangent 27 plus tangent 13 over 1 minus tangent 27 tangent 13. So because of this, here is plus, so we should be expecting, if you refer formula, it should be tangent A plus B. So if it's A plus B with tangent 27 plus 13, so we have tangent 40. Yeah, so that's how we apply the addition or subtraction formula. Now for this example, is making use of our chapter 8, if I remember, it should be 8.2, 8.3, with all the sine, cosine, and we apply. So take a look at example. So this solution, they say sine A equals 3 over 5, which means that sine A can, this one, which means that over here, this can be first or second quadrant, correct? ASTC. and tangent B, which is another